All right, on this example, let's do everything. Let's do find the inverse of this function and then also find the domain and range of both f of x and f inverse of x. All right, so our function here is 5x minus 2 divided by negative 11x plus 3. So rational function, those tend to be the most complicated when it comes to inverses. So following my steps, I'm going to rewrite f of x as y. And then after I do that, I need to invert all the x's and y's. So on the left-hand side, I'll have an x. On the right-hand side, I'll have a 5y minus 2 divided by negative 11y plus 3. All right, so third step, I need to solve for y. So right now there's a fraction. I don't want to deal with a fraction when I'm solving, so I'm going to cross multiply. That will get rid of the fractions. The next issue I see is that set of parentheses. I'm going to distribute the x in to get rid of those. So let's see here. X times negative 11y is negative 11xy. X times 3 is 3x. Okay, now there's no more fractions. There's no more parentheses. I can finally start moving things left and right. I'm trying to solve for y here. So I'm going to get all the y's on one side. It doesn't matter which side. I will move those to the right-hand side. So I already have a 5y over there. I'm going to add 11xy to the right-hand side. That'll leave me on the left-hand side. I'm going to add the 2 over, and I already have a 3x there. And now, keep in mind I'm trying to solve for y here. So the left-hand side's okay. The right-hand side, I see 5y plus 11xy. So I am going to factor out the y. That'll leave me with 5 plus 11x. And then I can divide both sides by 5 plus 11x. So that'll give me 2 plus 3x divided by 5 plus 11x. That is going to give me y by itself, or in other words, f inverse of x. Okay, so I've solved for f inverse of x. That should now allow me to find the domain and range of f of x and f inverse of x. Now the domain, let's put it up here, so the domain of f, that's actually a test 1 question. That's something you already know how to do. And f of x had a denominator of negative 11x plus 3. I'm going to set that not equal to 0 and solve for x. That'll give me x cannot be 3 over 11. Now, if you were writing this in interval notation, not too big of a deal. Negative infinity to 3/11, union 3/11 to infinity. I'm also going to write it in set notation because I think that's what your homework likes to do on this section. So that would be x such that x cannot equal 3 over 11. But keep in mind, we also know that the domain of f is the exact same thing as the range of f inverse of x, and that was one of my questions here. But only thing you need to watch out for there, you need to keep in mind, domain is x values, range is y values. So when I write this answer in set notation, I'm going to say y such that y is not equal to 3/11. So don't use x's there when you're talking about range. And then let's see here. I can also, I think, pretty easily find the domain of f inverse. Let me circle some of these other things. So this was the domain of f. This was the range of f inverse. Now the domain of f inverse, well, that's the function that we just found earlier. Its denominator is 5 plus 11x. I don't want that to be equal to 0. I'm going to subtract 5 from both sides and divide by 11. And again, if I was doing interval notation, that's not too difficult. And it's nice because it doesn't involve x or y. So you can use it for anything you want. But if the homework asks for set notation, okay, well then for the domain, That's x such that x is not equal to negative 5 over 11. Then I'm also asking for the range of f here. We know that's the same as the domain of f inverse. We just need to make sure we write it in terms of y because it is a range, not a domain. And that'll do it here for this problem. I'll put these two in yellow. So those two go together, the domain of f inverse and the range of f. And then the ones in blue there up above, the domain of f and the range of f inverse. Let's put our original inverse in a different color, and that's, you know, what we found first there. And we use that to find the domain of f inverse. We know a denominator cannot equal 0 there.